Hi, welcome to Vidyapeetham. In this video, we are going to discuss about the classification of codes. Classification of binary codes. So we have many classification of binary codes, numeric and alphanumeric codes, weighted and non-weighted codes, positively weighted and negatively weighted codes, error detecting and error correcting codes, sequential codes, self-complementing codes, cyclic codes, reflective codes, and straight binary codes. Now, what is numeric and alphanumeric codes? Basically, binary codes can be classified as numeric and alphanumeric codes. Numeric codes are codes which represent numeric information, that is, only numbers as a series of zeros and ones, that is, 8421, XS3, gray code, numeric codes are called as all these are called as the numeric codes. So numeric codes used to represent the decimal digits, that is BCD codes, that is 8421, 2421, 5211 are called as the BCD codes. So what is BCD? That is binary coded decimal codes. Now alphanumeric codes. What are the alphanumeric codes? So alphanumeric codes which represent alphanumeric information, that is, it may be letters of alphabet, decimal numbers as a sequence of zeros and ones. Example, ASCII code or EBC DIC code are all these called as the alphanumeric codes. Now, why we are going for these kind of codes? So, we are very much comfortable by using the decimal codes, that is decimal number systems, but in digital systems all the things are present in the binaries only, in the form of binaries only, that is zeros and ones. Although the binary system has many advantages, but that is, it is widely used in digital computers, etc. And so it is very convenient to work with the decimal numbers, but especially communication between the man and machine is extensive. Since most of the numerical data generated by man are in decimal numbers, so to simplify the communication process between the humans and the machines, so several systems of numeric codes have been derived to represent the decimal numbers as a series of BCD codes. So this is the purpose of we are going for a binary codes. Now, the BCD code is one in which the digits of a decimal coded or encoded one at a time into group of 4 binary digits. So these codes are combine the future of decimal and as well as the binary numbers. So there are a large number of BCD codes, that is, in order to represent the decimals between 0 to 1, 0, 1, 2, 3, 4, etc. to 9, it is necessary to use a sequence of at least 4 binary digits. Such a sequence of binary digits which represent a decimal digit is called as a code word. All BCD codes have at least 6 unassigned code words. That is called as the detailed explanation about numeric and alphanumeric codes. Now the next one is weighted and non-weighted codes. Now what is weighted and non-weighted codes? So the BCD code may have the weighted code and as well as the non-weighted code. So weighted code is nothing but it is a code which obey the position weighting principle. So each position of the number represents a specific weight. For example, 8421. So 8421, so in this code of 8421, so each digit which has sum of the weights of these positions, that is 8421. So these positions are fixed. That is called as the weighted binary code. That means for each group of 4 bits, so the sum of its corresponding weights of those positions, that means 8421, are fixed. Okay, so that is called as the weighted codes. So non-weighted code means, so it is a code which are not assigned with any weight to any digit position. That means each digit position within the number is not assigned or assigned as a fixed value. So that is called as a non-weighted codes. So the examples for weighted code is 8421, 2421, 84 2 complement and 1 complement, etc. These are all called as the examples of weighted codes, whereas non-weighted codes we can say accessory code, gray code are called as the non-weighted codes. So now what is meant by positively weighted code and negatively weighted code? Now what is meant by positively weighted code and negatively weighted code? So positively weighted code are those in which all the weights assigned to the binary digits are positive. So there are only 17 positively weighted codes. In every positively weighted codes, the first weight must be 1, second weight must be 1 or 2, and the sum of all the weights must be equal to or greater than 9. So the codes 8421, 2421, 5211 are some of the examples of the positively weighted codes. Now negatively weighted codes are those in which some of the weights assigned to the binary digits are negative. So that means the example for this is the codes 642 3 complement, 631 minus 1, 64 minus 2 minus 1, and 74 minus 2 minus 1 are some of the negatively weighted codes. Now the next one is error detecting and error correcting code. So binary codes may also be error detecting codes or error correcting codes. Codes which allow only error detection are called as the error detecting code. That means the codes which are only used for that purpose, okay, only used for detecting purpose, so that is called as the error detection code. Whereas the codes used to correcting the codes, that is called as the error correcting codes. That means, say for example, shift counter code 2 out of 5, 63210 codes are called as the error detecting codes. Now Hamming code are called as the error correcting codes. Now the next one is sequential codes. A sequential code is one in which each succeeding code word is one binary number greater than its preceding code word. Such a code facility mathematically manipulation of data. The 8421 and XS3 code are the sequential codes. The codes 5211, 2421, 642-3 are not a sequential codes. Now comes the self-complementation codes. A code is said to be self-complementing if the code word of the 9th complement, that is, so 9 can be obtained from the code word of n by interchanging all the zeros and ones. So the self-complementing code, that is, the code for 9 is the complementation of the code for 0, and the code for 8 is the complementing code for 1, and so on. So that is called as the self-complementing code. So for example, the code 2421, 5211, 642-3, 84-2-1 and XS3 are called as the self-complementing code, whereas 8421 and 5421 codes are not self-complementing code actually. So self-complementing code is nothing but, so we can say for example, so if 0 is there means the decimal word 0 is there means the 4-bit binary of 0 is 0000, and so if say for example, if 1 is there, the binary code for 1 is nothing but 0001. Okay, so whereas the binary the similarly for 8, similarly for 9, and so on. So if you see, the binary code for 8 is what? 1000. So 1000. So that means the if the binary code for 1 is nothing but 0001. The binary code for 8 is nothing but 1000. So that means both are self complement. Again another I'll say another example. So another example is nothing but, so the binary code. So the binary code for we can say 1, that is 0001 and 1000 we can say. So likewise, so it is a self complementing code we can say. So now the next one is nothing but, so say for if you see 8421 and 5421 are not a self complementing code. If self complementing is nothing but, so if you write one code and the last row of the code is a self complementing to each other. Say for example, if 2421 is there, so 2421 means, so that is a self complementing code, and if you say for 5211 code, and this 5211 code is a self complementing code. Okay, so now the next one is for the cyclic codes. So cyclic codes are codes is in which each successive code word differs from the preceding one in only one bit position. So they are also called as the unit distance code. The unit distance code have special advantages in that they minimize transitional errors or flashing. The gray code is called as the cyclic code, we can say. Next, reflective code. So the reflective code is a binary code in which n least significant bits for code words 2 power n through 2 power n plus 1 minus 1 or the mirror images of those for 0 through 2 power n minus 1. So the gray code is a reflective code. Now the last one is nothing but the straight binary codes. A straight binary code is used to represent the numbers using natural binary form as discussed. So it is a weighted code since a weight is attached to the every position. So that is called as the straight binary codes. Now we will see a tree form of binary codes. So that is, so codes are classified as actually two types. So one is the numeric codes and second one is nothing but the alphanumeric codes. Now in numeric codes again it is classified as weighted numeric code and non-weighted numeric code and self-complementing numeric code and sequential code and error detecting and error correcting code, reflective code, and the last one is nothing but the cyclic code. Now in weighted code again it is classified as two types, that is binary weighted code and the next one is BCD code. Now the next one is non-weighted code. So non-weighted code is classified as three types, that is XS3 code, gray code and 5-bit BCD codes. Next one is self-complementing code. The self-complementing code is classified as 8421, that is 5211 and XS3 codes. Now the next one is sequential code. So sequential code is nothing but 8421 code, that is XS3 code. Now the next one is error detecting and error correcting codes. So that is parity bit, parity code and a Hamming code are called as the error detecting and error correcting code. Next one is reflecting code, that is gray code, and cyclic code is also called as the gray code. Next, alphanumeric code is classified as ASCII code, then EBC DIC code and Hollerith code. Then BCD, again the BCD is classified into so many classifications, that is 8421, 2421, 333321, 4221, 5211, 5311, 5421, then 631 minus 1, then 7421, then 74 minus 2 minus 1 and 84 minus 2 minus 1. So these are all the classification of the binary codes.